Hello students, welcome once again, and today we are looking at how to find the interval and radius of convergence of a power series. So we have a series over here, and we have to find the interval and radius of convergence of this series. But before we do that, before you solve such questions, first you must find the limit. In that sense, what you are going to apply here is the ratio test. So you are going to apply a ratio test to check the convergence of the series, to check whether the series is converging or diverging. So we are going to start with a ratio test. So we start saying that using a ratio test, and the ratio test is given by the limit as n is approaching infinity. Then we have the absolute of a sub n plus 1 over a sub n. That so this is what we have now from the question given over there. Now an is just 4x 12 then to the power n divided by minus 3 2 here plus n, then also n squared plus 1. That is an. But a sub n is that whatever you see n, you add plus 1 to it. So we have 4x minus 12 here. Then we have n plus 1, then divided by minus 3 here. We have 2 plus n, then plus 1. Then also we have n plus 1 squared, then plus 1. So let's simplify that. So we have we can write this as x minus 12. We can have n here and also x minus 12 to the power 1, then divided by, now over here we can have s to the power, we can have just to the power n, then also we can have 3 here to the power 3 because 2 plus 1 is 3, then the n, since they are multiplying. So since they are multiplying, we can add the exponent is adding, and they have the same base, then we can write it this way. Then we can have n that squared plus 1. We leave it this way. So let's substitute a sub n and a n into the limit to find the value. So we have the limit as n is approaching infinity. Then we have a sub n. Remember, a sub n is this, so we have 4x minus 12 10 to the power n, then 4x minus 1 here to the power 1 divided by minus 3 to the power n, then we have 3 to the power 3, then also n plus 1, this is squared plus 1. Now this is, all of this is divided by a sub n, but immediately we introduce the multiplication sign, then for an, remember that an is dividing. So when we have a over n and we want to take the division sign away, we multiply. When we multiply, a changes with that, so it will now becomes the numerator changes with the denominator. That's what I'm trying to say. So it will multiplied by, this is the numerator and this is the denominator, so the numerator becomes the denominator and the denominator becomes the numerator. So we have multiplied by 3 to the power that, then multiplied by 3, and because I'm writing this in terms of an here, so we have this was the numerator and this is the denominator, but immediately we are multiplying, then this interchanges with that and this also interchanges with that. So we have the numerator as this, now it's 2 minus 3 to the power squared, then also 3 to the power n, then multiplied by n squared plus 1 divided by this, which is this 4x minus 12, then n. So let's cancel out and see. This will get rid of that, then this also will get rid of that, but still there's negative. Then also we have this will go get rid of all of that, so we have only 3 left here because this goes away and we have only 3 left here. Then there's a negative here, so negative will go away, and we have the limit as n is approaching infinity. Now what is left is 4x minus 1 here, then n squared plus 1 divided by 3, then we have 4, then we have n plus 1, this is squared plus 1. So we find the limit. So the limit as n is approaching infinity. Now let's factorize the x out. So I'm taking this out so that I'll only have so taking that out, let's do it this way: 4x minus 1, we have 3 here. I'm taking that out because I'm finding the limit with respect to n. So let's have our values in terms of n here. Now expanding n plus 1 squared is just a double of it, so it's just n squared plus 2n plus 1, then another 1, so it's just plus 2 here. Then we have that, so we can have this. Then over here, to find the limit of that, what we are going to do is we divide each by the highest power of the highest power in the denominator, and the highest power is just n squared. So we have n squared divided by n squared plus 1 over n squared, then divided by n squared here, divided by n squared plus 2 divided by n squared. Now 1 over n is equal to 0, so this goes away. Then over here too, this goes away, all of that also goes away, and I'm left with this and that, which will be 1. Then this place to 1, so we have 4x minus that, and the limit of all of this is just 1 being equal, so the whole thing is equal to 3, the absolute value of that. Then we have x minus that, as so you can see that now our limit is converging. Now to find the radius and also the interval of convergence of this power series, we are going to introduce a range of values over here, and it is within the range of -1 less than this whole, the absolute value of x minus 4x minus 1 divided by 3. Then also so this is greater than -1 and also less than +1. So this is the range, and this is how to find the radius of convergence. Now over here we are finding for the values of x, the interval of x, so we have to make x stand alone. So by doing that, we multiply each of the sides by 3. So we multiply here by 3, we have -3. Then we have if we multiply, 3 goes away, so we have 4x minus 1. Then we have here to be 3. Then also we can add, because when I add, this goes away, so I have 1 minus 3 here. Then I have 4x left here, less than 3 plus 1, so I have -2 less than 4x here, then less than 4 here. Okay, so let's correct something. This place is 12. Sorry, it's 12. It's 12. From the question is 12. So not that. So it's 12. 12 here, 12 here, then 12 here. So we rather had 12 to it. So 12. Then we had 12 here. So 12 minus 3 here, then we are getting 9. So we are getting -9 here, sorry, positive. Okay, so let's it's a bit of a mistake, I've corrected it. So we have 9 here less than 4x, then we have 15 here. So what I'm going to do next is to because I want the value of x, so I have to divide here by 4. divide here by 4 and also divide by 4, so it goes away. Then I have 9 over 4 less than the absolute of x, then 15 over 4. So now we have a range of values from here 9 over 4 to 15, and basically this is our interval. So our interval is between 9 over 4 and 15 over 4. Now there is another quantity we also have to find, which is the center. Now we had our value here as over here we had 4, we had 4x minus 12, 4x minus 12, and to find the center we equate this to x minus c, x minus c. Now here is just x minus 3. When I divide here by 4 divided by 4, I have x minus 3 being equal to x minus c. So we have this, we'll get rid of that. Then we have negative 3 equal to negative c. Then we have c equal to 3. So our center is 3. So therefore our center c is 3. Our interval here is 9 over 4 and 15 over 4. Now to find the radius, we can draw a normal line, and our center was 3, then interval of 9 over 4 and 15 over 4. To find your radius of convergence, is just the difference here. So the difference here is your radius of convergence. So it's just 3 minus 9 over 4, which is equal to 4. Then we have this to be 3 over 4. Then also 3, so 15 over 4 minus 3 here is also 3 over 4, and therefore the radius is 3 over 4, then 3 over 4. So therefore our radius of convergence is equal to 3 over 4. So we can have our interval as 9 over 4, 15 over 4, our center as 3, then also our radius of convergence as 3 over 4. Thank you very much, and I hope this section was helpful. I'll see you in another section. Have a nice day.